Hey guys, this is just a follow-up from last night's Teams meeting. So we were finding the intersection of the line and the plane, which hopefully you did, and then we were trying to calculate the angle between the line and the plane.
Pay attention!
And I have an assistant.
I'm
I
6.
think we were all wrong last night, kind of. Well, you guys were more right than me.
Oh dear.
Okay, check this out.
Got pen on me.
Okay, it's fine. All right, say we have a line and a plane intersecting. Cool, we want to find the angle between them. So I was suggesting that, okay, here's the equation of your line. So we know the direction vector of our line would be 2, 3, 2. That's our line's direction vector. So that's like the vector that's going in the same direction as our line. Then we have a plane here. This is the equation of our plane. So this is the normal vector of our plane. So a vector that's like perpendicular to our plane. So I was suggesting, hey, why don't we find a direction vector on our plane? Like there's an infinite number of direction vectors on our plane. I was like, cool. So last night we found this one. We found a direction vector on our plane by just doing the dot product between these two and making sure it equals 0. So like 3 times 1 is 3 plus
2.
-1 plus -2 would equal 0. So we just made this point up, or this vector up, by doing dot product to make sure they're 0. Okay, and we found it. So we used this formula that we used to find it's the geometric dot product formula, and we use it to find the angle in between stuff. So we found the angle to be 65 and thought, oh yeah, that looks good. Okay, so then I was thinking about what Zoe said, about how do you know you're finding that one? Like, what if the direction vector you picked is this way, and now you're finding this angle instead of finding like this angle? Like, how do you know what angle you're finding? Yeah, good question. I don't know. So I just picked another random direction vector on my line, and I just did it by making these equal 0. So 6 minus 8 plus 2 would equal 0. Cool. So then I did this formula again using the direction vector of the line, a direction vector on my plane that I randomly chose, and I did this. So I did dot product, so 2 times 2 plus 3 times 8 plus 2, whatever that is, equals, I don't know, I already did this work. Then I found the magnitude of each vector and did this, and I got, what did I get? 29 degrees. So like totally different angles. So which one's right? So here's what I'm thinking. We don't use a random direction vector on our plane. That's crazy. Who thought of that? Schmidt. Why don't we just use the normal vector of our plane? So if we use the normal vector of our plane, it's like, this is kind of more like James's idea, but I think a bit easier. So I think James's still works, but anyways, here's a quicker one. Here's the normal vector. It would be like this.
So pay attention.
Okay. It's gonna hit your line somewhere, wherever, it doesn't really matter where. So it's our norm. So we're gonna find the angle between the normal vector and the line, which is gonna give us this angle up here.
Ooh.
I don't want to do this whole entire question because I want you to still do it.
Yeah.
So we're gonna use the direction vector of our line, 2, 3, 2.
Even though I'm in grade 1.
Yeah. And we're gonna use not a direction vector, we're gonna use the normal vector of our plane, which is 3, -1, 2. And we can do our cos theta
3,
equals
-1, 2.
u dot n,
3,
find the magnitude of each, and we're gonna do it like this. And we're gonna find an angle for theta. But that's actually gonna be this angle up here. So then we just gotta figure out what this bottom angle is. And just using the fact that triangles add to 180 should be pretty easy to find that angle down there.
That angle. Even though I'm not in your class.
So that totally works. Anyways, I just wanted to point it out. It's actually not okay to use any direction vector on your plane, which, you know what, thinking about it after, that does make sense.
This one?
But if we use the direction vector on or the normal vector of our plane,
round circle?
and then we know that, we just realized that we're actually finding this top angle here.
There.
We were able to find this angle down here.
This angle.
Yeah, but that's a tricky question.
So that's good. Bye.
But just because we we didn't do a specific one like that in class. Hey, hold up. Doesn't mean it's like the worst question ever. It definitely challenges your brain, which I would like.
Ooh.
So anyways, that should be pretty easy for you to solve now. Okay, the end.